so just taking off where we left off, we need to go make our prompt, right? I think that's the most important thing right now. So we're going to create a new file under source, new file, prompt.js. Okay, and what's the first thing we do when we start a new file? We got to start doing a header. So / ***, just like we did before, at file prompt.js, at module. Again, normally we would be implementing these in full-on ES6 format, which would have modules. Now, this is not technically a module, but I'm just putting module in here because that's what I've always done. That's my practice. Prompt at description, a simple prompt module to get input from the user using process.stdin. And then we have another at requires curly brace at link https://www.npmjs.com/package/fs for file system pipe fs. And now we can copy paste the rest of this from our index.js, the header. Make sure we're going to the header. And we copy paste from the path down to the copyright. So you can put that right there and save that, and that's our header. Okay. And then we say, now I'm just going to go through this, and some of this code is really, really ugly, but it works. And I want to make sure that it works for Windows, but not for Mac and Linux. However, like I said, there is a third-party tool called Prompt Sync, which is an NPM module which you could use to work around this, and it does work on Mac and Linux. However, when we get to future implementations of a framework that's built around this, for those, I've implemented my own prompt.js solution, which is implemented in the code base so that I don't have to deal with third-party dependencies, and I still have the flexibility to properly support Mac and Linux. So I've solved all of that in future, framework code bases, but this one, we're just sort of hacking it together, which is why we're going to do it this way. So let fs equals require fs in string, single quotes. Let path equal require path. And again, normally we would be using imports, because imports, if it's a module and you use imports, then you don't have to use requires. And requires are kind of the older way, and imports are the newer way. Let base file name, which is the same as what we had before. Again, we're following sort of a template here. Path.base name, module.file name, path.extension ext name, module.file name, and that's going to get the file name with the file extension. Let name space prefix equal, and I'm doing a backtick here, prompt dot $ curly brace base file name. And then we have a dot at the end of that, and finally a semicolon. And then we do let term equal 13, and I'm adding a comment at the end of this line, and to describe what term 13 is, it is a carriage return. Okay, and so that's the ASCII code for a carriage return, and we'll talk about that ASCII codes here in a minute when we get further down. Now we're implementing the prompt function, which is the main part of this file. Oh, and by the way, you want your prompt.js file to be under src. For you have it in the root of your project, and you want to drag the file up into the src folder.
Okay.
Just a heads up about that. Okay, then we go function prompt, and we're going to give it a parameter this time. We've got some inputs, so this is how we write a function that's taking input to the function, and we're going to call the variable ask. So just ask right between the parentheses, open, close curly brace, We come back up here, and now we're going to, now the very first thing when we write a function, write the header for it right away. So /**, and notice that I have, I created the header, the function signature. This right here is called the function signature. The function and the name of the function, and then whatever parameters are going into that function, in this case it's the ask parameter, all together, that comprises the function signature, okay? And so once I created that function signature, then I go create this ****, press enter, and it creates this template for me that has the param, because it picked this up automatically from the input to the function. So it parsed my function signature and figured out what my header should look like, which is what I mean when I say it's auto-generating for you, right? So you want to write your function first before you do that, the rest of that. So you write this function prompt ask, and then you go back up and do the ****, press enter, and you'll get all of this automatically. Okay. All right. So now that we've got that, I can go back in and add at function prompt at description. And the description I'm going to put here is prompts the user for some input and returns the input. Okay. And then we have our param here, and it put a star inside these curly braces. That's going to be the type. And it put star because it doesn't know what type it is. But I do. I know that it's going to be a string. Okay. And what we mean by ask is we need to describe what ask is. Ask, and what we do when we're writing the description of a parameter is you sort of say, you can do this in your head. You'll get better at it as you do it more. But you sort of say in your head, what is ask? Well, and then you've got to answer that question. Ask is what, so you always put sort of, it's this implied, ask is what the prompt should display when asking the user for input. So this is adding this invisible ask is sort of helps you complete this answer as a proper English. And so that's why I say you just sort of ask that question in your head, because you have to answer that question in a proper English format. So we uppercase letter for the first letter of the first word of the sentence, any punctuation, period, proper grammar, and that's the answer to that question. What is ask? Ask is what the prompt should display when asking the user for input. And now we go down another line. We say at return, curly brace, string, and it didn't do the return, and it generally doesn't. You got to put that one in. Now, what is it returning? It is returning a string of whatever input the user gave. Again, I'm just sort of led you through that proper English format. What is it returning? It's returning sentence, a string of whatever input the user gave. Okay, and then we go down here, put the author, your name, and the date, at date, 2023-06-09. Okay, and then we get down to the function itself, and yeah. All right, so now we're ready to start on the prompt. This is where it gets really ugly, but again, we're going to see a little bit more of that boilerplate code here. So I'm going to just say let function name equal prompt dot name. Okay, and then we do the same thing as we console.log backtick begin. You can copy paste this from your other line. I'll write it out again. In the future, we'll copy paste it more. Namespace prefix, another $ curly brace, function name, space function. Okay. And then we need to just declare when we're beginning the function and ending the function, but we also want to declare any inputs to the function as well as any outputs or returns from the function, because these a lot of times are what determines how a function is going to perform its duties. So we're going to declare our console log the input, which is the ask. So console.log backtick ask is colon space $ curly brace. And in this case, ask could be anything. It could be some weird input. We don't know what it could be. There's a practice to do this to help if in case somebody passed an object or something, an array or something else in here. A good way to do this is to just do JSON, JSON, all caps, dot stringify, okay, and then pass the ask parameter to it. Okay, now that's going to convert the ask into a string if in case it's an array or an object or something else. I mean, I declared this ask as a string, but that doesn't mean that that's the thing about JavaScript. You can pass any old type object in there. JavaScript by itself does not have type safety. If you wanted to go to type safe language that's JavaScript related, then you would want to go to TypeScript, which has type safety around variables. But in this case, me just writing string doesn't necessarily mean that it really is a string. Like you could call this function and pass it an array or a Boolean or an integer or whatever you want. I mean, you can't pass a hamburger because, or you can't pass a picture of your grandma. Or maybe you can. I don't know, as a blob or something. There's physical things. I mean, you're not going to be able to pass those kinds of things, but you get the idea. You can really pass whatever you can call the function with from code.
Mm-hmm.
You can pass just about anything there. Well, this JSON
Okay.
stringify at least converts it to something that we can print out to the screen.
That's so it's 255 characters. I don't know if they expanded. Like apparently emojis are considered uh acceptable characters.
Yeah, well, I mean, I don't. I think it resolves emojis resolve as characters because that's how that's resolved. That's how you pass this into here. Um, but yeah, I mean, you could pass because it's code. You can pass just about anything that you can call it with. But this does convert it. If we didn't do this and somehow it was an object, then when it shows up in the console, it would just say object object, and you would be like, okay, what's object object? I don't know. So the JSON stringify improves the chances that you're going to see something that's meaningful, if in case it's not a string. So that's why we do that. We're going to say let input equal empty string, and if ask, now we do something here with the process.stdout.write ask. Okay, and then we're going to say let, and I'm going to do a multi-line thing here. So I'm coming down a line after pressing let, and I'm pressing tab over because this is going to be multi-line. So I'm going to say buffer equals uppercase buffer dot alloc, which is allocating some memory, 1024, comma, next line down, fd equals process. I'm still on the same line of code, but I'm doing it multiple lines now. Fd equals process dot platform. Platform equals, this is single quotes, win32. And we've got some stuff in here to try and see if it'll work with Linux or Mac, but it did not. I know this doesn't work, but we'll put this line in here anyways. Question mark process.stdin.fd colon fs.open sync dev /tty, and that is rs inside a single quotes, comma, next line down, read size, uppercase S, equals fs.read sync, and we're going to pass it a 0, comma, buffer, comma, 0, comma, 1024. And that's the end of the line. Okay, now when I press enter here, I got a backspace over to get back to the tab where I'm supposed to be. And you might not understand all of that, and that's okay. It's not the end of the world. I can talk through it briefly here. Buffer alloc is creating a 1024 byte memory. It's allocating 1024 bytes to a buffer. And then fd equals process.platform. This is determining if we're on Windows 32, if the current process is running on a Windows 32 environment.
Yeah.
And this question mark and colon is an if-then statement. Um, so if process equals that, uh, then I think it'll do this. And if it's this, which should be according to uh, Linux and Mac, then it'll do this.
Buffer.
Yeah. So
Yeah.
yeah, that's what this question mark and colon are, and
Yeah.
it's sort of difficult to get your head around. Question mark. So basically, it's like an if-then statement, and so if this is true, then it's going to do this down here.
Okay. Yeah. All right. What do we
And
call that?
if it's not
Well,
true,
that's
then it's checking this. Otherwise, this, if that's true, then do this.
a
And
condition.
yeah, it's an if condition statement, conditional if else statement. Basically, that's how that's working. So just wanted to give you a heads up. I don't usually use this syntax very much, but that's what was used in this code, and I just sort of used it because it was working and it worked for me. But again, don't like get hung up on this too much because let's just move on, right? Um,
Okay. Sure. I think it's interesting.
yeah, it is. It is interesting, and it's good to sort of learn yourself around these things and try to grow your brain and to understand it and be able to use it a little bit better because it does. If you're able to do this, it can make your code more concise. So it's a useful skill to develop. But yeah, if you can't get your head
I
around
keep
it,
harping back to pointers for some reason, but it's you just allocate so it's something in memory, right?
yeah,
Buffer,
don't worry about
buffer.
the buffer and the outlet right now. Again, you don't have to get hung up on that either. Just get the code in here and we'll make it work.
Okay, for sure.
Okay, so then we say input equals buffer dot toString, and we put UTF-8 in here, comma 0, comma read size, and then that is there. And then we say if input dot includes string, that's with an uppercase S, string dot from char code term. Now we're using that term that we declared above, that's 13. And this is a conditional check to see if the user pressed the carriage return enter key, right? Because the carriage return is sort of like the universal declaration that I have completed my input and I am pressing enter and I am done now with my input. So that's what we're checking here. Did the user press the enter key? If they did, then we want to capture that input. So we're going to say input equals input dot slice. Slice is a string manipulator function. We start from 0, which is the 0th index, and then we're going to go to the end of the string, essentially, where the carriage return is done. So we're going to say input.index of. Index of is another string manipulation function. String.from char code term, which is that carriage return. Going down to the end of the line, semicolon. Okay, so what that's doing right there, that line, is taking that input, whatever the user typed in, it's slicing it up
Gotcha.
from the 0th index, the first character of that string, and it's going to go to the end of the string, which is defined as the input, the index of the character that is the carriage return, which is term 13, which we defined up above. So it's going to capture
Press
that
slide.
string
Okay.
from the 0 from the beginning to where the carriage return, and it's going to return that string. We're putting it back to this input variable. I know a little bit complex. Again, don't get too hung up. We're just keep going. I'm just trying to explain a little bit so you don't get completely lost. And then we'll say else if input dot includes, and this is another way of capturing this for a different operating system like Linux or Mac. Single quote /r/n, which is essentially a carriage return and a new line.
Uh-huh.
Okay, that's the same way of doing the same thing. Space, curly brace, and now we've got another one, input equals input dot slice 0, input dot index of, single quote, single quote, /r/n. So basically these lines, both of them are doing kind of the same thing, except this one is pulling the ASCII code 13 as the
Uh-huh.
carriage return code. And this one is capturing the string carriage return new line, which is a different way of representing I press the enter key. It just depends on how different operating systems might represent that. Okay, so you asked about the std in. So standard in and there's an std out. Standard in and standard out are basically how you get stuff from the command console, right? So if you were to write a C, like a C program or a C++ program, you're going to use like cin and cout um, to get stuff from the console or print stuff to the console. And it's using that process.stdin or process.stdout, which is built in to the application process. This is part of like the operating system. It's kind of built
Yeah,
into every process.
I've heard an abstract about this before. I don't know how to explain it exactly. The console being an input output, and then you have, I guess, your to simplify it.
Yeah, that's right.
There's
I
in and
mean,
out.
every application has to implement, some basic stuff. Just it's inherited from like the operating system provides those as services to applications. Yeah, you can search it up and read a little bit more about it. The next block after this is just more of our boilerplate code, really. So console.log backtick. Now this is where we gotta log our outputs to the function. Input is $$ curly brace json.stringify again, open parenthesis, input, and we got to do a semicolon at the end. Again, console.log, and again, actually, you know what? This is where I'm going to start doing this. Copy, paste this begin, copy it, paste it down here, and change this begin to an end. Okay, that was easy.
Okay.
And then we do
Sure.
return input, and that's the end of the function. Now, there's only one thing left that we have to do. Module, export default, curly brace, and then we just say prompt. Okay. Now I'm going to do one other way of exporting because we need to basically take this function, this prompt function, and expose it and make it available to be called by the rest of the outside world. And the only way to do that is to export it. So I've done this with export default, but there's another way of writing export default. And the only reason why I'm going to tell you this other way is because it explains something interesting about JavaScript,
Okay.
which I want to go through the process of talking through this. So there's another way of doing this module export. It's a little bit more complicated, but like I said, it reveals something interesting about JavaScript that I want to explain. So what we can do is say module.exports equals open curly brace. Now we're defining an object here. This is a curly braces as an object. And I'm going to do square bracket, single quote, prompt. So this is the name of what I'm exporting, colon, open parenthesis, ask. And I'm using a special syntax here called arrow function. So equals and then greater than symbol, prompt, and then in parentheses, ask. Okay, and I'll talk through what this is. So here we're just exporting the function directly. Export default prompt. So the default export for the function is the prompt function. The default export for the file is the prompt function. And so it's just exporting directly. But here, this is a little bit different. Module.exports is sort of tying into what that export is for this module, which is not a module because we didn't actually define it as a module. Regardless, like I said, the syntax, let's just get over that. Then we have this prompt in the curly braces. Now this is what in JSON, we have the curly braces here. That means it's a JSON object, okay? And this is a way of giving a name. Normally when you're defining a JSON object, you would do like this, and then you would have name colon, and then you would have, my name, right? And so this name is a literal. In this case, it's a string, but you can't just pass a string directly. You've got to dereference that string, sort of like we did with pointers, right?
To keep value. So
to make it into an actual value is the best way to do that is to use these square brackets, okay? This, and if I was to write it like this, is essentially the same, right? Because this is a string and this is resolved as a string, but it's done in line with the JSON. And so that's what we have to do. You got to take a string, convert it into an inline, name variable that we could use like that. That's the syntax for doing that. Then we have the colon, which is part of the JSON syntax, the JSON object syntax. And then we get into this part over here. Now, the really interesting part about this is this arrow thing, okay? And what I want to describe, in JavaScript, this is called an arrow function, and it's a special syntax in ES6. So ES6 syntax, what this is doing, why we call it an arrow function, is because it's actually defining an actual function, and it's doing it all in this one line right here. So it's exactly the same as if I had written function and then the name of the function. But in this case, that is the function right there. Now, it's a little hard to get your head around that because, like, how is that? So what it's done is it's saying this is the input to that function, ask, and now it's calling the function, which is this call to this function, and it's passing this ask. So what I should probably be calling it, a better way of doing this is my ask, like this, right? Just to avoid confusion, so get it around in your head. My ask
Okay.
is being
So
passed
you're actually
to.
so it's self-declaring, I guess,
It's not
right?
self-declaring. It's
Something.
calling. It's a function calling another function, and the other function it's calling is this one right here. You
Oh,
get
is
that?
that how you written it? You by putting it within an array
Well, not
prompt?
not an array. I put it.
Well,
I'm basically inline declaring a function that's calling another function,
uh-huh.
and then that's how we call that function. And then however this input gets returned, it gets returned to the caller, and it automatically figures all of that out, like under the hood. It'll get returned to the function that then returns it, and we don't even have to declare it as a return because it just returns it. It does it automatically.
Uh,
It's
And that
it's
has
kind of
something to
weird.
do with scope. Oh, not
No, it
scope,
doesn't have.
rather.
Yeah,
A heap. I
not
guess the
really
heap
scope or heap. It's just how it's more like the call stack is
call stack.
figuring out in the syntax of the arrow function is figuring out how to do that in JavaScript internally. It's just part of the JavaScript syntax in ES6. It's a new
Okay.
syntactical feature that they've implemented.
Right.
And you're going to see arrow functions a lot. I've used them quite a bit in my code base. When we get into like more advanced stuff, you'll see it more. I just wanted to introduce it here so that when you see it, it's not completely alien to you. We've sort
I'm
of
trying to get my head around this because this is when I think I need it. It's more like C based or like class or object. I mean, they are like, because it's no longer like define function this, and now then it becomes like function or then you just declare a function, or you can write like you can write like function and then create a function within that function scope, or you can like
absolutely
write
yes,
a function, then declare it, then and then
yeah,
this is the new thing where it's like you're like initializing the function,
yeah. So
and and then write your
instead of always having to declare a function up here like this and have a function that has a curly brace and an end curly brace with a return and inputs and all of this stuff like this, it allows you to create functions that are a single line function, and you can put that
oh,
function inside other
okay,
functions. So you can have function inside of a function and then have another function that's doing something else inside that function,
yeah.
but it's all inside the
S-
same block of code.
okay, so what you were showing me with the function, the prompt function. So if we want to call this function again outside of the scope, we have to write prompt and then some params, right? And then
Yes.
where this arrow function, we don't have to do that. It just calls itself. Is that what you're
No,
trying to say?
you would still do it that way
Stuff. Oh,
because we're exporting this function as a function, a callable function from another resource. But it allows you to do all kinds of interesting stuff inside your code, whatever it is that you're writing in line. And we'll see
okay.
more examples of it later. When I just wanted to get the concept introduced to you. That's all.
Okay, yeah,
So
I'm trying to still understand that
yeah,
entirely
it
because that's a
definitely
big meat. That's a big part of
it is.
it.
It took me a while to figure this out and get it. You just, as you practice it and start to see it more, how it's used, and start to use it a little bit yourself and experiment and sort of play around, then you'll start to get it, into your head a little bit deeper, and it'll become more familiar for you. But yeah, it does take some time to get your head around this, and that's why I thought it was important to introduce it here. But I'm going to delete
Where
it.
when it's
We
being
don't need it.
called, when it's
Yeah, we don't
okay.
need it right now. I'm just going to save that, and now we're good. So now that we've done this, we need to go back to our index, okay, and we now need to import. First, we've got to add it up here. And I always try to do this. I try to, it's a matter of code quality for me. I'll try to, in my headers, I'll declare the order in which my imports are coming in. I'll do my internal imports first. So at requires, okay, and then say module : prompt. Because we're importing the prompt module. Again, it's not technically a module, but let's just get over that for now and just keep moving on. So I do the prompt here first, and then I've got my external path as a dependency import. Okay, so I always try to do my internal imports first and then my external imports. And I'm going to add a comment here, comment internal imports, and I'm going to add another one, external imports. Again, just a matter of having very clear, clean, well-described code. Put a uppercase I on internal and have a space between the comment and the beginning of that. Again, I try to keep it very clean so it's easy to read. Capital E on external, again, a space here. So it's very easy to read. And then we do let prompt equal require. Let me double check, make sure I'm doing this right. Yes, equals require, and then open parenthesis, single quote, period, / prompt, and it should automatically come up, and then you can just press tab and it'll pick it up automatically. Now we should be good. Prompt should now I need to uncomment this, okay, because I commented it out, remember? Save it again, control / is the uncomment. And now we save it, and now we should be able to go back to here and run npm start. And let's see if it works. Oh, we got a problem. Export token, export default. Let's double check something. Oh, you know what? I think we might need to have that other way of doing it. We might need to just for now because, yeah, let's do that. Let's switch this back. I think this is the new way of exporting with a module, and we don't have a module. This is not a module. And so we got to go back to the old way of exporting. So module.exports. Let's go back to that arrow function syntax, and it should work. So prompt, ask, arrow function prompt, ask. And we don't put a semicolon at the end of that one because it's part of this JSON object. So it's declaring a function inside a JSON object, and it's giving it a name called prompt. Yep, now that should, I think, make it work. So save it again, then we can go execute. I'll CLS for clear screen and npm start. Let's see if it works. Oh, we still got a problem. Base file name is not defined. All right, that is under prompt. Line 15, let's go see, capital N, working? Capital N. Yeah, it looks like yours is working. That's good. I just had a lowercase n in my base file name. Let's see, let's npm start. There it is. Okay, so now you can test this out and try to put in an off nominal entry like T or M, 8 or some just Z or X or whatever, something that's not X or Q, not X. Just something off nominal. Now it said input is, and it went back to asking you for your next input. Same for mine, right? But now if you try X or Q, it should exit. Oh, it did not. Try Q. No, still nothing. Exit. Does it work for mine? Mine exits. So there's something off with yours. Yeah. Let's take a look at that and see what we can figure out. Okay, right. Yeah, so that's a great question. Your question was if you enter the wrong thing, then it won't let you exit. And if we do want to type in the exit, then it'll exit out of the application. Is that what you're asking?
I believe so. It's looking for a particular input. If it doesn't get that it wants, that we specified, then it will exit the program, right?
Yeah, well, only if you type one of those exit inputs.
Oh, the exit okay.
Right, but if you enter something else, then it basically does nothing and it loops around and asks you for something else.
Okay.
Which, yeah, this is kind of how command line applications work. Is you have to define what it is that you want it to do, and you have to sort of parse an input and then link those two together. and it has to be very deterministic. Now you can write stuff like what we did here with the 2 uppercase to try to handle, off nominal conditions where the user enters something that almost looks like or is very close to, or, it has a different case context to handle different inputs. The user might be, just like we said, lowercase exit or all uppercase, and so you can handle these a little bit, but ultimately you have to break that down to a very discrete, deterministic, in other words, it's a determinable, ultimately, to be able to execute it. What we've implemented here, what we built here is a very, 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 very rudimentary command parser. Like the command is exit or quit, right? And it will exit or quit. Now, we don't actually have a command parser. It's just parsing the input and then doing the action. But it's the beginning of the idea. Now, the next level up is to actually go and build a parsing engine where you can have inputs that go in and it checks it against a table of stuff that it can execute, which connects up what it is that the user entered to something that they want to execute. And then that's like a command parser that leads to like a command tree, which does all kinds of really interesting things. And then that's when your application blows up. And that's how you build, a command engine with a command parser. And that's how you build a scripting language. Because I did this one day. Yeah, I did this one day, and I woke up one morning, and I'm like, wait a minute, did I just invent my own scripting language? Yeah, I kind of did. But I'm just describing how you sort of get there, right? Because you start here, and then you build all this extra stuff, and
pretty sweet.
Get there.
Thank you for showing me this. This is pretty sweet. I mean, if I like had like a table of like variables, whatever.
Commands.
Commands. GitHub, repos, just whatever. I easily iterate on them.
Yeah, you can do all kinds of.
I could show them on my. I could.
You build a portfolio.
I can navigate around.
Yeah. Exactly. You build a portfolio, and things just really take off from there. So yeah, it's pretty neat, especially as you build out and use this technology, this basic patterns to go and build really cool stuff. And we're going to build more. I mean, this is supposed to be a calculator, right? And we haven't built add and subtract and multiply and divide. And so we're going to do all of that. We're going to go build add, subtract, multiply, divide, and then we're going to do a factorial as the final conclusion. And once you do that, once we finish the add, subtract, multiply, divide, and factorial, then this is finished. And by the way, we need to go do one other thing. Since we're now done for the day, we need to push this stuff to our GitHub repo. So make sure you save all your files, right?
Yeah.
And now go to your folder. Yeah, git status, and yep, you've got there. So now we go git add space period enter. Right. You did that. Okay, now do git status again just to check and see what it did. It's a good practice. Okay, it says, what does yours say? Git status. There it is. Okay, so it's all been added. It's ready. It's staged for commit. So now we do a commit. Nice. Git commit -m space. Don't press enter yet. -m space open double quotes, and inside here we need to put the name of our branch. We always follow this pattern. Okay, main is the name of my branch. Main. Okay, colon. And then we're going to give a message. And we're just going to say start the project. Period. Make sure it's proper English. Colon. You have to do
I don't know. I get confused with React.
You need to do a semicolon, a colon after main. Okay. And now git status again. Okay. And it should tell you it's ready to push. Yep, it is. So now we say git push. And press enter. Uh-oh. I got to log in. Authentication failed for calc. So I need to log in, but I can do that separately. So go scroll back up. I want to just make sure what yours, if it did on yours. Okay, did it push it? Yep, it did. So yours is good. Yes, yours is good. Yours is 100% committed. And now you can go look on GitHub. It should show up like all this code that we just did on your browser. You can just go to your browser. Okay. Well, yeah, let's go ahead and wrap it up for the evening. And I guess we'll start next time. So
cool.
Appreciate your time, man.
You're awesome.
Absolutely.